163 missing ranges. So right here we can see we have a list of numbers and we just have to return the missing ranges. So here we would return 2 and 2 because between 1 and 3 we're missing 2 and 2, and in 3 and 50 we're missing 4 and 49, and in 50 and 75 we're missing 51 and 74. But then we also have bounds, so lower is 0 and upper is 99, so we're missing the range from 75 to 99, so we would have here 76 to 79. So basically any range that isn't in the list, and it's any number that isn't in the list of from lower to upper, we have to add it to a result and return it. So let's have a result array, and we know we're going to return that. So if our lower number is less than our first number, we would have to return we would have to add to result the lower bound and then our number subtracted by 1. This is because if our lower bound was 3 and our first number of our list, let's just say it's 5, right? Then the missing range here would be from 3 to 5, so we would just add 4. We would add 3 and 4 like this, because that's the missing range. And then this is for the first case if it's missing, the range is missing at the start. And then we have if it's missing in between numbers or missing at the end. So if we're missing numbers at the in between numbers, we have to loop through n-1 times because to avoid out of bounds cases. And then also we have a base case. If we have no numbers, we would just return the bounds that we're given in a list like this. Alright, so now let's handle this case. We'll loop through n-1 times and we have to check the difference, right? So if nums of I plus 1 minus nums of I is less than or equal to 1, we will continue because the difference is just 0 or 1, so there's no point of adding a range. And here else we would just add the nums of I plus 1 because that would be the next value, and then we would add nums of I plus 1 minus 1. So let me explain this right here. So let's say we have 3 and 50 right in our list. Nums of I is 3, and let's say nums of I plus 1 is 50. We need to add the range 4 to 49 because that's missing, right? So nums of I plus 1 would be 4, and nums of I plus 1 minus 1 would be 49 right here. And then that's how we add 49 right here to the result. And hopefully that makes sense. And then let's say that's the second case. So now we have the last case. Let's say our upper number 99 right here is greater than the last number we have in our list. How would we put it? Probably like like this. Yeah, and then we'll add the result. Add to the result. No, the number at the end of the list plus 1, because it would be 75 right here, plus 1, that's 76. And then we just add the upper bound right here. Let's see what I have. this is, yep, when we put the whole thing in a list like this. And I think this is an error here. Let's see. I inspect it, and then if n is 0, oh, right here, let's indent it wrong. Let's indent it wrong. Okay, I forgot to define n like this, the length of nums, and so as we have correct result. So the time complexity would be O of n for it's because of the numbers in the list. And then the space complexity, it would be like O of n also, because we're just using a loop. But yeah, we're just having a result. And yeah, let's see. Let's see if I submit it. That's good. Let's see what I wrote for my other one for the time complexity. Numbers in spaces also O of n. Okay, we're good. Alright, that's gonna be it for today's video.